Up next, we have another power-packed keynote presentation on artificial intelligence as we know it, a healthcare perspective by Dr. Masood Ikram, founder MellonAI. I welcome you, Dr. Masood, to deliver this keynote presentation, and the stage is all yours.
Good afternoon, everybody. Hope I'm audible, and then my slide is also available for everybody.
Yes, Dr. Masood, we can see your screen and your.
Thanks, Raj.
Yes.
I've been attending this session since afternoon, and my afternoon I'm from Chennai, so I've been seeing a lot of interesting talk already. Glad that it's going on well for everybody, and this kind of discussions are more important, to see where we are, stand back and see where are we at present for the future, as well as for the past, what we have learned from the past. So my presentation is more on AI, artificial intelligence, and I have this thing with me since like 3 years, and I've been working on AI. I'm a doctor, MBBS doctor by myself, and I made myself more and more in artificial intelligence. I've got more participants in AI and more technology available with me. I'll give a little brief about AI, what AI is, not go in detail, and then as a doctor's point of view, where do we stand and what do we have, and how can we take it forward for our own personal as well as our hospital experience, all put together. So intelligence, as we know, so this is more interesting point here is. Some of you might remember that when most of us were small, we were talking about TV as one of a stupid box and computer as your intelligent box. So we have been told, don't spend time on TV, spend time more on the intelligent box. But the irony in such a way today that this intelligent box has become more intelligent than us, and we are finding it problem because of that. So some people say AI is good, some people say AI is not good. There are a lot of conceptions, a lot of think about are happening. I'll just try to keep my perception, how I understood AI for myself. I won't conclude it by myself. I'll leave it to your wisdom and judgment to understand what AI is according to you, and how do you feel, and how should we take it in our lives, and how should we take it in our own healthcare industry or whatever industry you are currently into. Little brief on like history of AI, where does it start, and where does it happen. So you can see history of AI in 1950 itself. There's a very famous scientist called Alan Turing. Alan Turing is very famous those days because of his contribution in World War also. In 1950, he wrote a paper. From there, he said there is a capacity that computers can think. And in 1955, what happened? The word AI was born. John brought the word called AI, artificial intelligence. And 1964, so the first ELISA, which is our first chatbot, was made in 64 itself. And 1996 was a breakthrough year for all of us. Nobody could forget this thing. Gary Kasparov, the supermaster for chess, was been defeated by Deep Blue. IBM Deep Blue was a computer which defeated the chess master. So this is where people start looking towards AI. Why is AI becoming so powerful? And in this 2020s, the whole of 2020 is going to be called as the landmark for AI. Whether health or transport, education, all the sectors are looking in much seriously into this particular AI. So this is the Turing test I was talking about. So what Mr. Turing did in 1950, a simple test. He took 3 rooms, and of the 3 rooms, each room had one person, and the third room had one computer. And asked the 4th guy to come in front of the rooms and try to chat with the 3 rooms. 2 rooms of human and one room is of computer. And it so happened that the guy who was sitting outside might not able to identify of the 3 rooms which is human and which is computer. This is what the paper is all about. So that computer has a capacity to think, understand, and it can able to respond to you. And you're not able to understand, differentiate between human and a computer. This is the way the computer AI was being started because of this particular paper presentation happened in 1950. If you have to understand AI to the deeper level, AI is much larger, difficult to put everything in one context and talk to you about. I can talk days and like that. I try to simplify it with these are the means. These are the small pockets of requirements of AI available today. Because of this, AI is becoming so popular. Okay, one of the application what you can see here is like you have your chatbots, you have your computer vision, you have got machine learning, you have got PostNet, position tracking net, you have got cognitive learning, you have got reinforcement learning, and you also have deep learning. These are the things all put together in a pocket is there where we call artificial intelligence. A computer vision can able to identify you as we call it facial recognition. By technology, we call it computer vision. a machine learning. What happens in the machine learning? When we say machine learning, there is nothing called a machine available or computer available. It's a simple application. You give a detailed Excel sheet, a detailed Excel sheet to a machine learning, ask the particular bot or learning to learn the entire Excel sheet. Whatever data it can be clinical data, it can be technical data, it can be engineer data, it can be weather data, whatever data you have. Put all the Excel sheet into it, ask the machine learning to learn the particular Excel sheet, and you go and ask that particular machine learning, what have you learned? If you have to do this, what is the data says there? This is called machine learning. Chatbot, we have been using it like, every day, at least once we have used chatbots in somewhere. Position tracking, there's something called deep learning. A cognitive learning is what we are seeing it for the future point of view. A computer has got a cognitive way of understanding. That is something like, if you could put the outcome of machine learning, computer vision, chatbot, postnet, or deep learning all put together, and he will have a cognitive thinking, how humans have got. Cognitive thinking can give you a better output. And you also have like reinforcement learning. Suppose those days Google Maps were not that good because of reinforcement learning. You go and tell them, no, what you shared was not right. What you shared was not. You ask a particular song, you play the particular song, the song was not right. Then you go tell them, play it again. Machine learns, I've done something wrong. They try to improvise. Now it has come to a point that it is kind of working it somewhat decent. There's still a long way to go, but reinforcement learning has got so much into this particular artificial intelligence as it doesn't contribute. Very simple way to understand. Don't think you might be requiring this on a day-to-day life in your own use case, but very, very simple way to understand what is the neural network structure. Okay, very simple. So you can see there's something called an input layer. So there's a dog and there is a human being. Okay, you just take the heads of both dog and this thing and say this is dog and this is head. This is dog and this is human. This is eyes of a human. This is nose of a human. Hands of a human. Legs of a human. You ask them to learn all these. The hidden layer learns all these, and then when you give a picture, it says that okay, this is human being because the feature says head, nose, eyes, hands, and legs are something resembled to human being. So the output layer gives you this kind of output. It is very easy to differentiate between a human and a dog, but what happens if it is a cat and a dog? So for us, if we give both cat and dog, it's easy for us to identify, but see it in a very anatomical way, both are actually looks the same. Sometimes the height is same, they have the both trunk, 4 legs, tail, you have ears, nose, eyes, mouth, almost everything is same. You will not able to differentiate if you give you for example, in an outline sketch or sometime. But where does it machine learning understands now? This is where in 1980, a beautiful thing happened in the AI, which is called deep neural networks. A deep neural network was a solution where we are able to differentiate between these kind of things. So here's a very simple example here. Okay, there's a basket there. You can see a basket and there's an animal there. Now this animal is a cat or a dog. I'm sure people who are watching this, including myself in the beginning, was not able to identify this as a cat or a dog, but it looks like the same. Both have got fur, so we cannot able to make out. Then comes the deep neural network. So you can see here, there is neural networks have been different layers. There was not one layer, there are multiple layers. Consider each and every layer is for a respective, for example, head or a nose. So now everything, all the information goes through everything. It gets filters out. And the last one you can see is cat or a dog. It can able to say it is a dog. So finally, the animal there, computers identified that it is a dog. It is not a cat. You can see, and one more decent example in here. This is my Google Photos. My Google Photos is something I've been using it on a daily basis. I have a cat, my pet cat at home. On the left-hand side, what you can see is my pet cat along with my daughter, and my the cat name is Minnu. What I did, I went and searched Minnu, and it showed all Minnu's photos. It can able to identify the cat. On the right-hand side, you can see one more thing. I just searched cat, not the Minnu. It showed all types of cat in my gallery. So it can able to differentiate between 2 different cats. Forget about cat and a dog. So even today, if I bring you to my home, if I have got two particular white color, same Persian cats in my home, if I tell you this are the names, next time you come for probably even you might not able to appreciate which one is who. But today, computer vision can able to identify between cats. You give 100 cats, name them 100 different names, it can able to pick out which one is what. This is the level at which computer vision or the machine learning has advanced itself. This is something which I spoke about in detail already. machine learning and deep learning and cognitive learning and response learning all put together is your artificial intelligence. Now, in my first slide, I did mention that in 1950s itself, we were able to pick up what is a machine learning, and we got the name given to machine learning in 1960s itself. Why does it take so long today that today we are talking about AI, no, why not before? This is where something we call the triad has come over. The triad today is we have got high amount of GPUs, present today, which can process huge amount of data. And beautifully, all these GPUs via internet are available on your cloud. Suppose I buy one hardware, which is very expensive and it runs only one application. It's basically expensive for me to run that particular application. All I need to do is put it in the cloud. And today, internet is there in nook and corner, so you don't have to worry about it. And I don't have, and my GPU is also shared GPU. So my GPU, availability of GPU is much larger. It is shared, so the cost has come down. Since everybody has got internet, and I make an application in one corner of the earth, and other corner of the earth can able to use the same application in different ways. So this is what is the beautiful environment created around this machine learning and artificial intelligence, which is giving us an edge towards the entire AI. AI in healthcare. So we might be talking about AI healthcare is there, not there, good, not there. But you see, AI in healthcare is already there. It is there in so many different ways and so many different forms. This AI healthcare has also been further classified. You can see patient-facing, tele-facing, you can see research-facing, mental health point of view, medical imaging point of view, hospital data analysis point of view. So AI is there around you all. We just have to understand what clicks, what is not click, and where are we? Are we contributing towards AI, or is AI is growing by itself? Because we all are intelligent. We all have got our intelligence capacity. Are we contributing our intelligence capacity to make AI better? I said some time back that the AI was not able to pick up the song which I asked very well. Today it can able to do it. Is it happening same in the healthcare? If I'm giving my information to the healthcare so that the AI can become better and can serve us much better. This is something we have to see AI in healthcare a little bit in detail. Some of the products which I have in my company, like Farbill, Sure Diet, I have a diet and Capimo. I don't want to be standing a salesman. You can visit the website and learn what we are, but there is a significant amount of contribution has been done from my side and everybody from everybody towards the healthcare on the AI. We have also been working on so many different projects. Can you predict an ECG? Can you predict discharge summary automated? I don't want to sit and stand and write discharge summaries. Upload 100 discharge summaries, it can give you a particular discharge summary. What is it right for this particular thing? Just do a final correction and then just walk away. Auto ICD coding, the speech recognition. In physiotherapy, I'm using PostNet in physiotherapy to make sure that the angle at which they're tilting is right or wrong, and they can do it without a physiotherapist, and they give you a report that this guy has worked for half an hour and his angles were right and total number of this thing is right and how much time he has spent. Every information will come to you on your application. Auto health check, AI dashboard, pathology. These are some of the works which have been happening in my own company itself. Then understand what is the AI happening throughout the world around you. I don't have time, running out of time. So this is one of the, I will not play this now. I'll just brief you about this. This is a small Alexa model which is kept in front of us. So what happens, Alexa? What happens in Alexa is, in telemedicine, we're talking about so much of telemedicine. One big problem happening on telemedicine was somebody has got a toothache. Okay, they take an appointment and a tele appointment and they end up at the dentist department. And that is, they say no, it looks like this is an earache, so you have to supposed to go to the ear department. This kind of thing happens between pediatricians and physicians and department. What this Alexa used to do is it will take the entire history by itself. It will ask you questions by itself and it's by itself. And at the end, it will make a chart for you, make a file for you, and will give it to the respective department that your form, your file has been created, an appointment is fixed, and so date. And when the doctor opens a particular thing, he doesn't have to waste enough time on going through the entire process and entire clinical history and the current history, and see he can straight away see what is the case, what is it, have a small conversation, and go for his prescription level. This has already been created. I'm not playing this because of time issues we have here. Hello. Okay. Publication versus application. This is one of my favorite slides, and I literally beg all the doctors to give focus and try to understand what is this about. Okay, we are living in the world where we always talk about publications. I have this many publications, you have that many publications. I'm not against it. It's good. You should have more amount of publication. Publication makes your research much better. But what happens in a publication is you use the data, you analyze the data, you make an inference out of it, and you publish the particular data. And this particular publication of yours has been sitting in some kind of an very good, decent amount, whatever amount of publication available is available over there. Is it applicable as an application for you to use it? No. So why don't you make your own publication, whatever publication you currently have, why don't you make your publication into an application? And what you need to make an application, the first 4 steps are same. You have to use data, you have to analyze your data, you have to inference the data, and whatever outcome has come, ask the machine learning to learn that Excel sheet. Ask the machine learning to learn the Excel sheet and the particular question, what you're thinking, what is coming in your mind, you put it across, it will give you back. For example, I have a doctor sitting here in Chennai. He is known for not doing too many cesarean sections. He will wait. He knows, this guy, we can still wait for this lady. I went and picked up his publication, all his data, and I created an application. A new patient is coming to anybody somewhere, anywhere in the world. All you need to do is enter the gravida, gravida, and everything, all the information, height of the patient, everything put together. That based on this previous experience of this particular guy, who's an experienced doctor, it will give you a probability that, what are the chances that this lady will go in for cesarean? What are the chances it may not go in for cesarean? This is a kind of small, basic, simple publication is converted into an application. And most of the people throughout the world can use application now in a simple way. This doctor is there today, alhamdulillah, but God forbid something happens, his work should not go wasted. A lot of our works are getting wasted, we don't realize. I tell you, for example, Egypt had built pyramids. Go back to Egypt, say, build one more pyramids. They forgot how to build their own pyramids today. So we are working today, we think we have a lot of inference in our hand and we are doing a lot of work in our hand today. It will be forgotten someday. Your publications are a good way to store it, but applications are a better way to use it in applications point of view. This is where we're looking in for. A very quick way that, how other worlds are looking into AI. China is definitely advancing in AI. Other companies also doing better in AI. I'm already short of time. I should close this by now. You can see this is a 4D process. You have decided to do an AI. How do you approach for an AI? We call a 4D approach. You have you dream it, you define it, you discover it, and then you drive it. So you have your data, you have your technology, your people, your organization, and you environmentally enclose it. We do this kind of workshops in different places and give them a good output. What is a good application you should be making it based on your data and going forward. You're supposed to watch out for these 4 important things when it comes to your own data. GDPR, okay, the fine for GDPR is somewhere 20 million euros or 4% of your global income. Even Google had to play in Portugal, kind of 10 million euros, I guess. Always prefer open AI, not closed AI. Ethical clearance, ethical body, have ethical body, put it in ethical body, get ethical clearance, and make sure agreement with the guy who's giving you very good application has a good agreement with them. Thank you so much. I'm sure I was almost right on time. I made more on time.
Thank you, Dr. Masood, for the insightful keynotes. And I'm sure our eminent delegates have benefited from your enlightening speech. And yes, you were right on time.
Thank you.
Thank you once again. And please have a great rest of the day.
Humanity, rising to the challenge of a lifetime. But we're not done yet. Better has just begun. Let's make healthcare reach everyone.
Hi, good afternoon, everyone.
Let's push this world forward. Because together, we make life better.